Hello friends, and I welcome you all to Bosons Botany, and I'm starting with the last simple permanent tissue, which is sclerenchyma. So here I start. The first point about sclerenchyma is basically it is a dead tissue, or you can say the cells are dead. Why? If you recall, then I have already defined this particular case in my previous video, that if a particular cell is dead, then it is meant to have very thick wall. So the reason behind the dead cells forming this sclerenchyma tissue is why? Because of thick walls. So this is a very important criteria for making a cell dead. And in case of sclerenchyma tissue, all the cells are dead in nature. Therefore, sclerenchyma is the dead tissue or composed of dead cells. So the next point, if we form our next point from the first point, then the cells are highly lignified. So the cells are having thick wall. Cells have thick wall, or you can say the cells are highly lignified. Lignin deposition is very prominent in case of sclerenchyma, and therefore the cells are dead in nature. Again, if you recall my previous videos, I have also told you that due to protoplast, the cell is a particular cell is living. If protoplast is present, then a particular cell is living. But in case of sclerenchyma, there are no protoplasts, so the cells are dead. So there are no protoplasts. So no protoplast in case of sclerenchyma. So there are three main points explaining one another very well. So if the cells are thick wall, then they are meant to be dead. If the cells are dead, then they are having thick walls. If thick walls, then the walls are highly lignified, that is, lignin deposition is very much prominent. And if the cells are dead, having thick wall or highly lignified, then no protoplasts are present. So these 3 points are very important, making sclerenchyma distinct from the other 2 types of simple permanent tissues, which were parenchyma and collenchyma. Now here I come with the first type of sclerenchyma, or the first classification of sclerenchyma, which is fibers. Fibers is a particular type of sclerenchyma tissue or a category of sclerenchyma. So fibers are basically, wait a second, sorry for the inconvenience, my pens are not working very well, I don't know why. So the cells of fibers are, or fibers in whole, as a whole, the fibers are elongated, having pointed ends. The ends are pointed. Pointed ends. So fibers are basically elongated cells with pointed ends. So something like this. These are two pointed ends and elongated in nature. So fibers are elongated with pointed ends. Many times the walls get so much lignified that the lumen gets reduced or obliterated. What is a lumen? It is basically a central cavity, and in case of fibers, many a times due to high lignin deposition or due to too much of lignin deposition, the walls get highly lignified and the lumen becomes lumen becomes reduced, or it is obliterated, or it is sealed completely in case of fibers. But this is not very common, or you can say it is not seen in every case of fibers, but in sometimes this is very prominent. So lumen is closed or reduced or obliterated due to highly lignified walls. So it is not necessary to have lumen, or if lumen is present, then lignified or lignification should not be too much. Or if lumen is not present or it is not very clear, then it is very um, well explained that lignin should be there, that is high lignified wall should be there, because the lumen is not clearly visible. Now the second type of point, or second point, is pits are very well formed, which means pits are very well developed. Pits are highly conspicuous. Pits are the characteristic um, characteristic features about fibers. If you remember, I have already told you about pits, not in very detail, but pits are basically um, small holes, or small uh, you know uh, portions, small depressions present in case of many tissues, and fibers is one of them, in which pits are present, which are very well developed. These pits are oval or rounded in shape. Many a times middle lamina is present in case of fibers. This is again a very important feature about fibers. So middle lamina is present, which is a very characteristic feature about sclerenchyma. So presence of middle lamina, presence of pits, these are some very important characteristic features about fibers. Some other points regarding fibers are commercially very helpful, very much in use in case of commercial purposes. For example, for getting hemp from cannabis sativa. Cannabis sativa is a plant from which we get hemp. So commercially very important, we get hemp from cannabis sativa. So this is a very important feature about fibers, which is commercially very helpful, getting obtaining hemp from cannabis sativa. Also we get jute, from hibiscus cannabinus or madras hemp, from hibiscus cannabinus which is madras hemp. So these are some important commercially useful things we get from fibers. Hemp obtained from cannabis sativa, jute from hibiscus cannabinus, which is also known as madras hemp. There are two main types of fibers. That is, fibers is also differentiated into two main categories. So the first type is Xylem fibers. And the second type is extraxillary fibers. So these are two main categories of fibers: xylem fibers and extraxillary fibers. So xylem fibers, we get xylem fibers from some meristematic tissues from where the other xylem cells develop and contribute or constitute an integral part of xylem. So xylem fiber is basically derived from meristematic tissues. Xylem fibers derived from meristematic tissues from where we also get other type of xylem elements. And extraxillary fibers, their combination is known as bast fibers. So extraxillary fibers will combine to form bast fiber. Bast fibers. So extraxillary fibers get combined, they aggregate to form bast fibers, and found in position other than xylem. So their position is very peculiar. These are placed somewhere else but not in close proximity to xylem. So the position of xylem and position of position of xylem fibers and position of extraxillary fibers is different. So present away from xylem. So extraxillary fibers are present somewhere away from the xylem elements. Now the second type of sclerenchyma which is commonly known as sclerid. So the second type of sclerenchyma is sclerid or sclerids, widely distributed in plant body. So its presence is very high, it is abundant, it is very widely distributed. So widely distributed, and not longer but broad, single or in groups. So these are not long but rounded, broad, and present singly, or that is present as an isolated tissue, single or in groups. So sclerids are widely distributed, not long but rounded. This point is not very important. So rounded, this is not very common thing to say. So not long, broad, single or present in group. So sclerids are not long, they are broad, might be single or in groups. Found in cortex and pith of gymnosperms and dicots. This is very important. Found in cortex and pith of gymnosperms and dicots. So sclerids are present in cortex and pith of gymnosperms and dicots. They are also present in some leaves, and you can also say present in the mesophyll part of leaves, and sclerids are totally widely present there. So present in several leaves, in bracket I am writing mesophyll, where sclerids are widely distributed, compactly arranged, very well formed. So these are some sites or places where you can find sclerids in abundance. Now this is very important point regarding sclerids. So if you observe guava or any other fruits like sapota, which is also known as chikku in Hindi, these fruits have some kind of grittiness. If you chew them, if you eat them, you can actually feel some kind of hard things, some kind of grittiness, something which is like a very stony like thing, and these are nothing but sclerids. So sclerids are present in fruits and seeds. They give the grittiness of the fruits like sapota, or chiku. Also guava. Found in fruit pulp. So guava is having sclerids in its fruit pulp. So if you eat guava, the stone like things, the seed things which we perceive as seeds. These are not basically seeds, but these are sclerids, which give you a grittiness kind of thing, or grittiness kind of texture, which is very peculiar in these fruits like sapota, guava, and found in some kind of seeds as well. Provide hardness and strength to the seed, forming the seed coat. So why sclerids are present, or why sclerids are needed in case of fruits and seeds? Because need sclerids because they give strength and hardness to the seeds, forming seed coat. So importance of sclerids in case of fruits and seeds is basically because sclerids give strength and hardness to the seeds, forming seed coat. So seed coat is a protective layer around seed, and sclerids basically provide strength and mechanical support to these seeds, forming seed coat. Commonly the pits are simple, rarely bordered, and may present or may not be present. So I'm not writing in much more detail about pits. So pits are present or absent, and the borders are not very prominent. The borders are not very thick in case of sclerids, if sclerids have pits. So if pits are present, then the borders are not very prominent, not very thick if pits are present. So I think that this video is helpful. I have actually messed up a lot in this video because I am writing and simultaneously I'm speaking, so I'm not habituated with this type of action or this type of activity. I have tried something new, so please let me know how was this video, and in my next video I will start with complex tissue. So please watch my videos, like my videos, subscribe my channel, share my channel, my videos, and do give your suggestions, your comments, so that I can improve. Thank you for watching my video.